continue from here. Yeah. So Bhavya or Suma, Teja,
Yes, sir.
Teja, can you tell me what are the physical topologies? It's on the
Sir,
screen.
bus topology, ring topology, mesh topology, star and hybrid.
Okay. Another few topologies is which is that separate part, but it is point to multi-point tree
Point to
topology,
point,
tree
extended star.
topology, etc. Okay. The bus topology structure is like this. This is a devices are connected to the a backbone wire. Okay, it is a main backbone wire. Okay, is the thickness. No, earlier days of cable TV, it is a single cable, and that TVs are connected to this um, main backbone cable only. Okay, so this is also a topology used in organizations earlier. So the devices are connecting to this backbone cable. Now any packet is traveling, so everybody will receive through this backbone cable only. Only thing is, it's a later implementation of protocols. They will use it. This is called a bus topology. So for example, this is APC, BPC, C, and D. And advantages are very simple to configure, very simple. So you need a cable, run the cable over the devices or where the devices are there, and from the we can able to connect. So mostly they use coaxial cable for this purpose, copper cables. But there is a problem. What it is? If cable is broken like this, if cable fault is occurs, only these up to devices can able to communicate. Later B cannot able to communicate C. A cannot able to communicate C or D. The remaining communication will be stopped. And because of other devices won't get a proper signal and the voltage levels are low, so obviously they won't communicate each other also. Okay, so it's very difficult to troubleshoot also. Easy to configure, but difficult to troubleshoot. That is a bus topology. The next topology is ring topology. Here in this one, the devices are one device is connected to another device is connected to another device. Like this, it is connected. Of course, it is also very easy to configure. But there is an algorithm based on it works based on some algorithms. How to communicate, you have to define it. You have to configure how it should be communicated. For example, this is A, B, C, D, E. So here it is. If A want to communicate it to C, so only one way direction. Okay. So only one way direction. It is like this. A will send a packet to B and B send a packet to C. C want to communicate it to A. Then C send a packet to D and D send a packet to E and E will send a packet to A. So it is either clockwise communication or anti-clockwise. It is a kind of closed circuit also. So it means the end of the device will connect it to the starting device. Okay. If you want to add one more device, again you have to reconfigure. Not a simple connectivity and disconnectivity, guys. Again, you have to configure how it should be communicate. Okay, it's a little big headache for organization. Second, if line is broken, Okay, if line is broken, the further communication will stop. Means A to B communication is there, but A and B cannot communicate it to C, D, and E. But C, D, E can communicate A and B. See, it is A, B, C cannot communicate. A, B cannot communicate it to C, but C, D, E can communicate it to D. A. Okay. Another one is if device is down, same problem. Further communication means one way of communication will stop. So that is another fault in this ring topologies. So which topology it is? Ring topology. To avoid some issues, for example, only clockwise communication. So people put a double ring. Double ring means two connectivity. One side of connectivity will go for a one side of communication is clockwise, another side of communication is anti-clockwise kind of stuff. So, hmm, recognition. Okay, that's a small. So, so here it is. One more topology. I have to buy a new mouse. I have a devices. In this ring topology, I connected one device to another device, other device is connected to another device, other device is connected to next device. Like one device is connected to next device is connected to another next device, another next device. The last device is connected to the first device. It is form a ring. But this is another topology. One device is connected to all other devices. One device is connected to all other devices. For example, I have A, B, C, D. So A is connected to B, A is connected to C, A is connected to D, A is connected to B is connected to A, B is connected to C, and B is connected to D, and B is connected to B also. Same thing, C is connected to D, E, A, and B. Like this. Every device is connected to all other devices. Anybody can guess what is the this particular topology?
Star topology.
It's a mesh topology. So normally we take it as a wrong thing. It is because for people easy to write, they put a star and explain. So I wantedly done that one also. It is called a mesh topology. It is highly redundant topology. If in case if this wire is broken, no problem. Remaining communication is going on. Okay. Only A to B direct communication is not there. But A can communicate to B, C, D, sorry, except B, it will can able to communicate all other devices. For example, this particular device is down. No problem. Remaining devices will communicate each other. Only this particular device is not communicate. But it is complex. Lot of wiring is required. So I have a 1, 2, 3, 4, 5 devices are there, but each device is connecting with the 4 wires. Means 4 NIC cards are required to connect. Okay, so this is so mesh topology is a total mesh topology. It is complex and difficult to troubleshoot. Complex to configure, difficult to troubleshoot. Which device, which line, it is very difficult to find. But redundant. The advantage is one line or maybe one device is down. Remaining communication is it is very rarely used in organizations. Of course, we are not using bus topology. Okay, we are not using ring topology. Of course, no one is using mesh topology. But mesh topology is still rarely used in where is like a SAN type of network, storage area networks, core routers, core server, like a data centers. They use a mesh topology for redundancy purpose. Means one line is failed, no problem, other server is available kind of stuff. In generally, in our organizations or even a home network or office networks, we are using the star topology. How it is look like? There is a centralized device. Either it can be hub or it can be a switch, and all devices are connected to this centralized device. Okay. Okay. So this is can be a hub. Hub is a one of the networking device, or you can use a switch. Hub and switches both are used in a LAN communication. Creating a simple LAN, so we are using it's a centralized device. Everybody is connected to every device is connected to our hub or a switch kind of stuff. You can use hub or a switch. If you have more devices, like you have a 10, 20 devices, then you can go for a switch. If you have 4 devices, 3 devices, then you can go to the hub also. Here also some problems are there, but before that one, good things. For example, if this wire is broken, no problem. Still we can able to, other devices will communicate it. If a device is down, no problem. Other devices will communicate. Okay. But if your centralized device is down, total communication will stop. It is very easy to configure, but you have to pay for an additional device, hub or a switch, which we are using. That is, again, you have to pay, not just the cables, also you have to use pay for a this hub or a switch kind of stuff. Yeah. Again, advantages, easy to configure, easy to troubleshoot. Easy to configure, easy to troubleshoot also because hub or a switch having a LED status. So if one line is broken, automatically you can get the line status. So it is like this. Hub. Okay. You can see there is a hub. The LEDs will tell you the line status. Okay. A device status means the actual device is turn or off. The wire is, if it is broken, something you can understand from the line status and link status, you can be able to get it. Even for a switch also. Yeah, this is a very big switch. You can see any good looking switch. Yeah. If you see here this side, there is a LED status is there. This is LED. So one, if you are connecting, connection is good, LED is blink. If connection is not good, LED won't blink. Even the color indication also, link status, you will get it. Okay, at connectivity. So you will understand. So where is an issue? So we can troubleshoot. Even this device is down. Still we can understand. So communication is stop, we'll check in a switch. So of course, a switch problem or a hub problem, we can easily replace it. So easy to configure, easy to troubleshoot. Okay, not redundant, not like a mesh topology. It's not redundant and easy to scalable. What is scalability? You can able to increase the size of your things like either storage or network or anything. Okay. So it is a mesh topology. In a mesh topology, if I add one more device, again I have to go to each and every system and configure and connected all these things. See how much it is complex to scaling it. It's very difficult to scale, but this is very easy to scale. Means in my network, more devices are there. Okay, so I will buy another switch. I'll connect this switch to here and I will connect devices to this switch or a hub. So simply I extended my network. Earlier is simple network, simple one single network. Now it is my segment size is increased. This is extended star topology. It's in organization, not only one computer, right? So there are several computers. So now with one single switch, well, maybe it is a 24 port switch or a 48 port switch, but there is a limitation. I have hundreds of computers. So I don't throw a old switch. I can just extend it and I can able to connect multiple devices. This is extended star topology. So this is a star topology. If you are extended, the extended star topology. This is star topology. Okay. So this is the mesh topology. This is star topology. Guys, this is main important topologies. First topology, ring topology, mesh topology, and star topologies. So compulsory read about advantages, disadvantages, and how it is connected. Point to point. Point to point can be anything you can say it's a point to point. For example, you have two computers and you connect it directly. It is also a point to point. You have a router and a router connected through some WAN connectivity. It is a point to point. We are connecting to multiple routers or one head office is there, is connected to multiple branch offices. Okay, like this. This is the point to multi-point connectivity. One head office is connected to multiple branch offices. Point to multi-point connectivity. Okay, so another one is T topology. That's not really a topology. It's a combination of different topologies. See, it is like a bus topology. There is a backbone wire. To this backbone wire and separate star topologies are connected. See, there is a switch and there is some systems are connected like this. Okay, it is a tree topology. So main is a tree. You guys understand up to here? See,
Yes, sir.
very good. Very good. So then so we have Tejaswini next. Tejaswini,
Yes, sir.
yeah, tell me type of networks.
Mainly there are four types. It is LAN, WAN, CAN, and MAN. Whereas LAN means local area network, with CAN means campus area network, MAN means metropolitan area network, and LAN means wide area network.
Very good. Very good. Yes. Okay. So another few additional networks recently there are added. There's so many are there, but by the name, I feel it is very funny because I know these four things from last 20 years almost. Okay.
Sir,
LAN
VPN is
can
missing.
VPN is a virtual private network. It is not comes under this network. Okay. Yeah. Yeah. We can add that one also. Even it is only four, mainly only four. That two are important. One is LAN, another is a WAN. Okay, these two are very important networks. But people are added, keep on adding in, even though it is syllabus, because I never hear these things. But I like it is more reasonable is um, personal area network because nowadays people are having so many personal devices. Like I have a mobile phone, Bluetooth, hotspot. I can connect my smartwatch. I can connect my smart shoes, smart clothes. It's a personal area network. Me and my devices connected each other. So it's a personal area network. That is okay, reasonable because now everybody has it. Not connecting to internet, guys. Your all devices are connected to each other. Home area network. What is home area network? Again, it is also reasonable. Nowadays, we have a smart TVs, smart LEDs, smart ACs, smart home appliances, Alexa, Google Home Nest. We can able to connect all these devices. We can control it. Even though we can connect it to printers, smart printers are there, Wi-Fi printers also there. So within a home, you can take a printout without connecting to the cable through the Wi-Fi or direct Wi-Fi direct kind of stuff. You can take a printout. Okay. So this is a network which is a limited range on either personal or a home area. Of course, people are putting BAN like that. I don't know. Again, SAN is also storage area network. It is not comes under any kind of area network also. But people are asking, so what is about a SAN? Some people are including in this one. It's guys, this SAN is not our regular network. It is used by enterprises. Storage area network. It is for storage purpose. Storing huge amount of data in a high level, high organizations, enterprise organizations, cloud organizations. There are storing huge amount of data into SAN storage devices. Okay, so it's through they will access it through. Anyway, we put a name that is called a VPN because some people are including this thing. No problem. Virtual private network is not a physical network. Through the physical network, we can able to communicate our remote organizations. For example, I'm in my organization, my core network thing, my servers, or maybe my application in a different site. I'm in Hyderabad, but my application running application is in Delhi. For example, it is in Noida office, or maybe in Bangalore office or Pune office. So I want to connect it to it. So through public, it is unsecure. So my organization to that office, what they will do, they will connect through some WAN connectivity. I am accessing it through virtual private network instead of doing the laser lines, permanent WAN connectivities. So to reduce the cost, I go through the internet. I can access my network from different locations. That is called VPN. VPN does not mean what we are using now, that is open VPN, accessing some websites through VPN. That is not the part, okay? Anyway, that is also VPN, but a real VPN is I'm working, so my database server or maybe my web server is in different site, different location. So I want to access it. So I cannot access without going to that organization, right? So I cannot put that server into public directly. So what do we do? We use VPN servers. So we can connect to the VPN through public net internet. And so I can access my servers, my database, my applications, or my server kind of stuff. Okay. So that is a VPN, virtual private network. But main important networks are local area network, campus area network, metropolitan area network, wide area network. Local area network, local network only within the organization. It is your private network. Campus area network. Of course, if you go for colleges or campuses like, Tech Mahindra University campuses are there, Cognizant campuses, HCL campuses. Campus means multiple buildings, so they can able to communicate each other. So simple LAN, either it is a single room or maybe a single floor, maybe it is entire building. So this is the limitation. Geographically, textbook wise, I am telling, okay, because the LAN and WAN original definitions are different. I'm telling definition. So it can be a single room, or can be a single floor, or it can be entire building. We can connect all the devices together and become one single LAN network. Campus area network in the colleges, universities, organization campuses, having a multiple buildings, each one having their own LAN network. And you combine all the things together and make them communicate each other. So that is called a campus. Means within this campus, they can able to communicate. They cannot communicate outside. Outsiders cannot communicate inside a campus. This is campus area network. What is metropolitan area network? Within the city. In the city, there is different networks like that. Police department, a hospital department, or maybe road related department, um, the city mayor, metropolitan mayor is there. Na? So our fire department. So all these departments are connected, and so they can able to communicate. So I want to apply for a driving license. I can sit in home and connect it to my network, so I can apply. So how we are doing with internet now? So within a metropolitan city, they are connected each other, so they can communicate. Of course, only some places still they are using maybe metropolitan area networks, but nowadays we are connecting directly internet, so globally we can able to access. WAN connectivity, wide area network. For example, in Los Angeles, I have a my head office. I have my servers, web servers, or maybe SAP related servers, cloud means sorry, SAP databases, SAP application running servers are in Los Angeles, for example. Actually, ours is New Jersey. Okay, just for okay. In another site, for example, Melbourne in Australia, in Melbourne or Sydney, I have another site is there. There also there is servers. In India, I have my own servers. So I'm working in Indian side. So they will connect each other like this. Okay. So I can access their infrastructure through the WAN connectivity. It means through globally I can able to access. Okay. So global connectivity. This is a LAN and WAN connectivity. Okay. So two more points, guys. One is intranet, another one is internet. So we'll tell up to here and I will give you a small break. What is intranet? Intranet is like a LAN, means within the private only, local network. Intranet means local within the private network only. So we are not able to. If you are in intranet, you can't communicate outside of your network. Means through internet you cannot able to communicate within the network. I am my server. Okay, simply in my network, I have my own storage server is there, web server is there. For my organization, I'm accessing it, I'm developing a, people are accessing it. So within my organization, within my home or within my network. Okay. So we're all connected. Okay. So that is LAN network or intranet network. It is private network. What is a public? We are accessing so many things from internet. So you can see it is, I'm accessing this site tutorial point. I'm accessing this Cisco site. I'm accessing this is a NASA website. Yeah. So here it is. This is some research related. Yeah. This is space research related. Okay. So I can access. This is GitHub. This is my yeah, WhatsApp. So this is Google Docs. See, I'm accessing my Gmail, everything from internet, right? So that is a public network. Anybody can able to connect public network. Anything available in public, we can able to. So globally connected and public network. But there is a difference between WAN and internet. Okay, there is little differences are there. One more is extranet. Extranet is more like a WAN network only. It means internet means within your private network and you are connected to another private network, that is extranet. So I'm not going through that one. I'm going through this WHO kind of stuff. Up to here clear, guys? How many networks? Anything?
Yes.
SO, HO. Small office, home office. So in your home, how we are connecting to the network, or in a office, how it is connected. Okay. How it is, we are connected. Think like this, our LAN network. The LAN, you want to connect devices. So we need to connect it to a switch or a hub. And maybe in our organization, for example, I have a some server is there, like my learning web server, or maybe ticketing server is there. Voice ticket. After 2-3 days, I will show you that server also. Okay. So I'm accessing from within the LAN only. So I don't require any internet connectivity to communicate from here to here. I don't require any internet connectivity. So simply I can communicate directly. No need of internet. This is my LAN connectivity. Of course, for example, you want to communicate wirelessly. Now everything is wireless communication only, right? Okay. So I need a wireless access point. So this is called a wireless access point. So I have a wireless devices. What are the wireless devices? Your laptops, your mobile phones, your tablets, all these things are wireless devices. You can connect to this wireless access point so you can communicate each other. It's not your home Wi-Fi router, okay? It is just an access point. So we can just like a LAN, just like a switch or a hub, we can connect to this device wirelessly. Of course, you want to do both the things, you can connect to these two things each other. So with wire these devices, with wirelessly these devices, everything can communicate each other. Okay. Now I want to connect to internet. So I need a device called a modem. What is this modem will do? Modem is trying to connect our internet service provider through the telephone wires. And nowadays we are getting a fiber optical cables. Okay. So in between how it is connected, we don't know. Depends upon ISP. Okay. From modem is trying to connect you to the internet service. So modem will send a signal to ISP. This is my user ID password. So ISP will verify and provide a connectivity. Now we are getting internet up to here. Okay. And internet having a public network. Internet is a public network. And this is different network. This is your LAN network, your private network. How it will be? Internet should be how it will become inside your inside. Then we need a router. The router will route your network to outside of the network. Need a router. What is the router will do? Route one network to another network. So this is different network. This is different network. This is different network. So this is the router will make a communication between different network. Router will make a communication between different networks. So this is our home office. Okay, small office kind of net. Nowadays, we are getting different way. We are not seen. I told so many devices you may not seen in your home or office. In office, what we have? Anybody will tell how we are getting internet? Simple Wi-Fi router,
Vehicles.
right? Simple Wi-Fi router. And it is getting connected, either it is Jio or ACT or Airtel. It is connected to ISP. The wire is connected ISP. Now that is also not there because Jio and Airtel launches this air kind of stuff. Okay, so simple device. Okay, the wire. If you have wired devices, for example, if you have a computer in your home, in backside there is a connectivity, so directly you can connect it to the cable. If you have wireless devices, happy you can connect it to your wireless device. But you know this router having so many things. It act like a wireless access point for connecting wireless. To connect wide devices, it contains a switch or hub kind of stuff also. And it is a router. And it contains modem also. So earlier I showed so many devices, right? This is hub or a switch, wireless access point, router, modem. This single Wi-Fi router is act like a all these devices. It act like a modem to connect ISP. It act like a router to connect your internal network to external network. It act like a wireless access point, okay, to connect wireless devices. It acts like a small hub or a switch to connect a wide devices. That's why we may not see all the devices in our home or office kind of stuff. Hub or a switch used to connect LAN communication purpose. Wireless access points are used to connect devices wirelessly. So that type of network we call it as a WLAN. LAN is local area network. WLAN is wireless LAN. What is WLAN? Wireless LAN. So what we use in WLAN, we use a wireless access point. Router is internetworking device. So we shown already in the first thing is router is here and internetworking. This is a network. This is a network. How we are connecting different networks using router. Router is a internetworking device. Connect and communicate one or more networks using this network. Modem use it to connect your ISP, Internet Service Provider, to access the internet. So your Wi-Fi router is act like a modem to connect ISP to get internet. The router is to your connect and communicate between different networks, inside network to outside, outside to inside. Wireless access point is to connect wireless devices, your wireless LAN. And of course, the backside of Wi-Fi router, we have a um, connectivity server. And two more points, okay. And your Wi-Fi router also act like a default gateway and DHCP server and DNS server also. Because when you are going to communicate outside of the network, so where is that another picture? Yeah. You are going to communicate outside of your network. You have to go through this one only. You have to go through this one only when you are communicating outside of, like I open Google page. Google server, in my home, I don't have Google. In my office, it don't have Google. Google server is in different location. It can be in Chennai, Bangalore, right? How to reach through my default gateway only. It means through my Wi-Fi router only. That's it is act like a default gateway. My device is getting an IP address. Device is getting an IP address. I am not configure any IP address to my laptop, but it won't be there in by default. In my office, I got some IP address. I will show you that one. So my laptop got an IP address. Okay. I didn't configure it. It is automatically configured. By whom? DHCP server. So who is my DHCP server here is my Wi-Fi router. In my home, if I go to my home, I open my laptop, I will get some other IP address. Depends upon my home Wi-Fi router. Okay, home Wi-Fi router. So that is, it act like a DHCP server. DHCP server provide an IP address to the devices. Local DNS server. So in outside there are a lot of DNS servers are there, but main thing is when you open anything, you open a Java T point. Java T point, I don't know what is an IP address. I need an IP address. It has to come from the DNS server. So I don't have any separate DNS server. It will forward to this Wi-Fi router. So your Wi-Fi router act like a modem. It act like a wireless access point. It act like your default gateway. It act like your DHCP server, DNS server, and of course it act like your router also. So these are some devices. Next, anyway, we'll going to discuss about different devices and how it is look like, what is their purpose. Take a 10 minutes of break, guys. Just 10 minutes only. Relax. Okay. Then we will discuss.